Okay. How are you guys doing now? You um you guys should expect to be doing quiz number 3 now. Shortly. But I think that I'm gonna open it on this weekend. After this process, I'm going to move that quiz forward. I think the opening date is the 24th. I'm gonna move that forward. I'm gonna go through this and move it forward. Because you have another one to do. You have more to do. And you're midway the semester already. So let me just with my pen. So my pen. All right. So we are typically looking at these figures. I don't think I'll be able to move them. I just have to copy them because the only other way is to grab them from your original file on this device. Let's see if it's on this device. Because I had to switch between laptops. And so as a result of that, I'm on a little bit of backpedaling here. So you had some questions from this sheet here, both of them. They would have been from, no, I don't think this one. Not this one. It would have been more from the other one. This one. No, it's not this one. Oh, it's not this unit, sorry. Let me go to the unit. I want to pull back the question. I want to have them live from the section. I think this is the section. So I'm gonna open both of these and pull the actual question back again. Because those fact that I had to switch between devices, I can't move those questions. I can see them, but I can't move them as I want to move. So let's work with this. We'll put it there. It's a little bit better for that then. So that you can see that properly. Are you guys seeing what I'm doing? Hello? Can somebody talk to me? When I work this one again.
Not really, sir.
You can see what I'm doing, right?
Not really.
Not really? Hold on. It's paused. Hold on. All right. I'm just putting back the questions up properly. I have them, but some of them, one or two of them might be a little bit faded, so I was trying to. All right, let me reshare, make sure that you guys can see. All right, where am I? I think I'm over here.
Don't try to.
Can you see that I'm on a page here in OneNote?
Yes, sir. Yes, sir. Good.
Yeah, I'm on a page in OneNote. And what I'm doing, I was trying to just bring up these so that you can actually see them properly because I had to switch devices. So this one here, I can see, but it's faint. That one might be a challenge. I might have to use this as this. Let's copy it and bring it up. I'm gonna carry it down. And then I'll move them around while I'm working. I'll try and create some space. All right, I might do this one first. All right, and then or this one. I'll do this one last. All right. And I have this other one here. Number 2. That's the order I'd set them up on the other device. But this question I may have to find it so as to, I think I have it open. Let me see if I can pick it up. I have it open on another. Some else.
Sir,
Yes.
there are people in the waiting room wanting to join.
Let me just see who's in the waiting room. Oh, I apologize to them. All right, quite a bit of them. Yeah. What else is here? Oh, it's so much of them here. Oh, all right. All right. This is only happening because I have to switch device. That device is a wonderful device, but it has served its useful purpose in terms of the speaker. Speaker's gone. So you probably, I don't know, I couldn't hear you. Maybe you can hear me with it, but I will have difficulty hearing person. with it. One of those lovely things, but with time it ages, you know. All right. All right. Are you seeing it? One note before I start. So what I'm gonna do, I'm gonna review the unit that you guys would have been given in class. This one here. Are you seeing what I'm scrolling here in Word? This is the tutorial sheet. Are you seeing everything? Oh, let me stop sharing. I'm gonna do it another way. I'm gonna share everything. I'm gonna share everything. So anything that I'm
Sir,
doing.
you are seeing it, sir.
All right. So I'm all right. I just want to make sure that you're seeing it. So this one, I'm gonna work this one also. And then no, I'll take that one from the sheet. And that one I'll take from that sheet. All right, let me get out of this one, this sheet here now, and just go into another one. So this one now, I need another the moments one. That's the moments one is right here. All right, so this was the one that you all right, I'm gonna do this
Excuse me,
one
sir.
here. Pardon me?
Sir, is it a case where you want we to work it first, or
No, no, no,
the
no, no,
different?
no, no. I'm just picking them up. I'm just picking them up. I'm just picking them up. I'm gonna start. I'm gonna pick them up. Because what happened, I had set out to work 4 questions. But as I was explaining to the guys before, here we have it. Okay, all right. So we have it. All right. And we have it. So we'll do that one, number 4. I'm gonna do this one also. So the order is kind of a little bit mixed up, but it's all right. We have about 4 questions here. We do all 4 of them. I had to copy them over. Wasn't really what I want. All right, so this one first. So this question, all right, so we're on the unit which called moments and coupling. They want you to, let's get this wider. So they want you to find the moment of the force about P, right? Right. And I'm gonna write, so if you can't see it, please let me know. All right, I trust that you all are having a good Saturday evening. All right, I'm still trying to get myself together after a morning session there. All right, so this one says, determine the moment of the force about. Oh, so you have a frame, guys, it is pinned there like a piece of metal bolted on a wall. So what we have along here is right there is like an it's a rivet, it's pinned to the wall. They want you to determine the moment of the force about point O. So all of the force here, so we're gonna just review. Firstly, when you see the 4, 3, 5 triangle, what it means is that this right angle, this is 5, this is 4, this is 3. And then they're saying that if you notice the direction of the force is down here. So you're going this way, right? And then you coming down in the virtual, right? And then you're going positive. So you're going negative in the virtual, positive in the X. Now you can do this 2 ways. Some people might be comfortable in calling it theta. You call it theta, you could say then that sine theta, all right, is equals to 3/5. Why do I know that? Because this side, this angle is pointing to that side, right? Now this side is this side down here in the X is an adjacent side to the angle. One side is adjacent, one side is opposite. So this is opposite. All right. So that's all I got. And then now cos theta would be equals to 4 up and 5. Can I get some lines here? I think the other one that I set up before Add line. How do I get the line? 1 second. Because the lines will help some of you to be seen. What's going on? No water is on my mouth here. Hang on a second. My mouth here. Next step. Hang on. Can I get some line here? 1 second. I want to see if I get some lines. Where do I get the line? The lines here. I want to get the line. Give me a second. Go to the line. Here. Yeah. All right, beautiful. So let me put that line. So the lines are there now. Let me get back into what I was doing. Those are again. With here. Yeah, here. Here. Okay. All right. So we have line. All right. Let me expand a bit. All right. The lines need to be a little wider, but it's all right. So does the line help or help it confusing? Which one do you prefer?
Sir, everything all right. Just
Okay, all right, fine. So I was hoping to have it spread a little wider so I could write it, but it's not. It's
no, sir. When we have a problem with this, sir. No.
Pardon me?
When we have a problem, we just say to you.
Okay, all right, wonderful, beautiful. All right, so that now is the angles, how you find those ratios. So as a result of that, we are able now to look and saying, let's find the component in the x. So the x component, right, are for the 100 force, which is acting this way, 100 Newton. It's going to be, you know, it's going to be 100 cos for the x, it is 100 cos theta. So you could write that now as 100, and the cos theta is what, 4 upon 5. So you put that, and that gives us, how much is that now? 200. How much? This goes in there, 20. So that gives you 80. 160. Sorry, is that 160? Am I correct here? 160. Oh, I don't have my calculator on me. Anyway, all right. So we have that. What else do we have now? The y component. So the y component is going to be 100 sine theta in right. And if we could color them, so we have one going that direction, one coming down. Right?
Excuse me, sir. How did
Yes.
he get 160?
5 into 100, how much we got? 20 times 4, is that correct?
Sir, shouldn't it be
That's
80?
8. Sorry, yeah. Oh, I'm going a little bit fast. Hold on, where's my writer? Where's my writer here? Yeah. All right. And then, so that is, and then the other one, so this work out to be 100 times sine theta is what? 3 upon 5, right? So that now gives you 5 to this, so is what? 20. So you have what? 60. Right. So you have 60 there. Okay. All right. Now, all right. Let's move on to policy. Now, after we have, so the value that we have for these, let me clean up this a little bit. All right. So the value we have for this going that direction is, what's the value in the x again? 80 newtons. And this one coming down is 60. And if you notice carefully, I do not write any minus signs there. Why? Hang on a second. Let me get a calculator. Hang on a second. So, all right, so everybody understand how to find those components. All right. So we're gonna go now and we're gonna take moments about O. So we're going to take moments all right, about O. All right, so it means we're gonna sum the moment symbolizing, and we're gonna take anti-clockwise direction as positive equals to 0. All right. And if that's the case, right, let's see how this writer is writing. When I get it right, a little bit bolder. So, all right. So, for the first one, we're going to look at the, let's look at the X. This one here. I probably should let it be blue. This one here in blue. All right. So the one blue, right? So let's concentrate on the blue. All right. And then we have the green. All right. So you can see them differently. So I'll write them in the color. So for the blue, the force is like it's going that way. All right. And remember, you're gonna turn it about this point right here. So if you turn it about that point, the force is running along here. That's the f of x component is running in that direction. The distance from where it is turning is 2. Right? So it is going that direction, all the ways. Right? Now it's gonna cause a turning effect in the clockwise direction, but we taking anti-clockwise as positive. So therefore, this is a force that is gonna be turning 80 times 2, but it is minus. Everybody agree with that? Who don't see that?
Breathe that over again, sir.
All right, let me write it like it's too bold now. All right, let me reduce the color. And go again. So
Just rub over under.
yeah, so right here, we're gonna take the points about here. So this is the distance. This is the distance from the force, from the point that you're turning. All right. So the force is what you call a sliding vector. It's going across. Or some people call it transmissibility of force. It's sliding vector. It's going across. This effect is right here, but it is going in that direction. As a result, you turn it about O. So it's coming that way, right? But it is 2 meters from O. Can you clearly see that? So it has a right angle. Now, remember that moment is equal to force times perpendicular distance. So your perpendicular, your force arm is a 2 times the force here. So and it's turning about right here. And it's right is here. So that is giving the right angle, but it's turning right about here. All right?
Hold on, sir. What are you using the most today?
Let me silent this is right now. What's gonna happen? Let me silent for it. All right. What for the students even turning all right. So you turn it about O. So it's force times this. What was the question being asked? Go again.
If you're
Repeat.
using the most to direct what you're saying.
You see that my order is low. I'm hardly hearing it. That's why I've switched to a different.
Sir, we weren't seeing what you were using to point, and we weren't seeing the points that
Are
you
you
were
not
making.
seeing anything that I'm doing?
Yeah, we weren't seeing it before. We're seeing it now.
You seeing everything now?
Yes, sir.
Oh. So look at the page. So all of my writing, you weren't seeing anything?
No, we were seeing the writing, but we weren't seeing the points that you were making when you were saying at this point and it's going from that direction. We weren't seeing
Okay,
that.
but when I circle them, are you seeing it now?
Yes, sir. We weren't seeing that.
So you see there now, I circle that point. So that point is O. So you turn the body around O, and I use the blue for the X component. So you're turning and you're pushing at this point here, so but the effect is you turn it around O. So therefore the force is coming along there. I want to erase and put it back. I can't. All right. So I put back it. So it's coming that way. The effect of the force is coming across here. All right. This is your 90 degree right here. But the effect, you turn it around O right here. And so the force is going in that direction. And so you get your moment right here. You make the moment with the force. The distance across up to the force, you get the moment arm. And the moment arm will cause the body to be turning in the clockwise direction, which is minus. So it's minus the volley is what? 80 Newton times the 2 meters.
Sure. So why you use minus and it turn clockwise?
Because the clockwise is going to be negative.
Evening, sir. Letting the people in a waiting room, please.
All right, I turn off my fan behind me, so I should hear you better. All right.
Yo, bro, you just made the clockwise negative
So
because
from
I
my
just
direction, sir,
choose.
from my answer, I got 140 clockwise. 140 Newton meter clockwise.
All right, I'm not finished yet. Allow me to go through it, please.
Yes, sir.
Everything who is in the waiting room, this is who you are. Wait, because when I'm in that section, I'm not necessarily gonna see. So if you alert me if anybody here in the waiting room, because I'm just gonna be on a field glass. My Zoom thing is gonna be shadowed. Only person here to be looking. I'm looking at me.
Yes, it's video is buddy.
All right, so everybody is here now. Okay. So, all right, I think that's it. Everybody is in. I don't think that anyone else is in the waiting room. That's that looks like it. Right, so let's go again. All right. Let's go back. I don't understand. What kind of markup is on my screen? So, all right. Allow me to go to for the benefit of the person who have where so you're saying you got a different answer from mine? That's what you're saying? Somebody was saying that a while ago?
So you don't quite finish with the question
Yeah,
as
yeah,
yet,
man, I
sir.
don't finish it. So I'm just taking it stage by. Yeah?
Yes, sir.
Yeah, I'm working with that. So therefore, the force is going along here and it's turning around there. So it's going to be 2 times 80, which is going to be 2 times 80 give you what? 160. All right, but hold on. We're gonna take it stage by stage. I'm gonna erase the unit beside it because I'm just gonna do system. Just like how I would normally want to work. All right, I'm gonna leave the units out for now and put them in afterwards. All right. All right, come on. So it's time 2. All right, let's clear it up. All right, so that's for the clockwise turning. Now we're gonna do the anti-clockwise, and I'm gonna use a different color. Let's use green. So for green, it is coming down. All right. Now, so its effect. Remember, essentially, these forces are acting right at that tip here. But in terms of analyzing them, we draw them out here just to let you know. So they're essentially right here. And the blue is right here. All right? They are both right here. Essentially. But we just put them outside there to show you. I could even put the blue up here just to kind of explain where it is active. All right, so concentrate on the one that I've drawn for clarity. So we're using green, right? So it's coming through here, coming through here, coming down. You agree with me now? But you see where it's acting through?
Yeah, one, sir.
Okay.
So it's coming through, but you want to take the moment from, let me erase the blue now and use a different color. I read all of them. So it's really turning around here for the green. But what is it? What is the moment arm now? So you have force coming down, straight down, and then you have the distance. It is this distance to the force. It makes right angle right here coming down. All right? Anybody need clarification? I show you where the force is, let's draw them. So the force is coming right down through here. All right? So that's your force. What's the value for your force now? The value for your force coming down is 60. 60 newtons coming down here, but 5 meters from O. So now it's going to turn the body also in the clockwise. Anybody disagree? Anybody disagree so far?
Sir, repeat that again, sir.
So it is turning the body around the earth point of origin O right. That's the thing now. That is island O. All right. So it's turning the body around here. Remember, so you have, let me draw it out here. So you have this is O. You have the force coming down. The force is coming down 6. But the moment the distance from O is 5. So that's gonna give you a turning effect. That's it. All right, and it's gonna turn it in the clockwise. It's also going to be a minus 60 times 5. All right, equals to, well, you don't have to really equal it to 0. Just ask it to get the moment. All right, we're not gonna really equal it to 0. Let's not equal it. Just get the moment. And
Sir, I understand you get a 5 then, sir, if you perpendicular distance, you know.
Because of O. From O, bro.
this
The
one,
perpendicular
so
distance.
see the 5 here coming out to where the force acting to. The force is acting from this point here. Right here. You get what I'm saying? So this is
Yes, sir. So it's acting clockwise.
so this is the
Force
distance coming
acting.
across here. This distance here. That is the distance to where the force is. So you have to find, you always look for a distance to where the force is before you take the moment. So that's so each force, and this is important, you know, because when you go to the next topic that I'm gonna do, frames, it's important you know how to take moment. These are basically easy. So we look from where we're taking the moment. What is moment? Force times perpendicular. Let me rewrite that. Let me rewrite this one here. It's force and we symbolize it. And it must go up. Perpendicular distance. Alright? That is a symbol means perpendicular distance. So this perfectly maps out the perpendicular arm right here. So you have the distance from O and it forms. So based on that, right? Based on that, you have 5 times 60. All right, what that work out is? When you work out that, let's work it out. So we have it now. 80 times. We have 80 times what? 2. That was the first one.
Yeah, 160 plus minus 300.
160.
Minus 300.
300. And that value gives you the value gives you how much is that? Add those values. 460 minus 460 Newton. Okay, remember it's force time distance is a moment, right? And you notice where the moment is. So because we consider anti-clockwise as positive, and if it was clockwise, then I suppose you would get a positive answer. So it depends on this one is just the minus sign is attributed to the convention that we feel. Solely to the convention that you have.
Excuse me, sir, not to interrupt you, but there are persons still in the waiting room.
Okay. Beautiful. Ready. Hold on, I need to get rid of it. I'm not seeing it because I'm in like a blackboard mode. Let me see here. Oh, it tells me that keep going. Just indicate to me when all right. But I'm not seeing my Zoom in there. Right. All right. Okay. Getting back to 1 minute. Where's my 1 minute? It disappeared. Am I not still sharing? Um, my OneNote page has gone. Where is it? I'm in OneNote. Let's see if I get that page. All right. So here we're back. Automatically. I'm not take up and keep the Zoom. Waiting for it to report together. All right, so you'll have to tell me because I'm not gonna see them on there. All right, so that's where pretty much finished with that part. All right, so we have taken a moment about O, all right, for that. Once we have worked out the forces correct, the only way it's incorrect is if we didn't work out the forces correct. All right, and just double check all the calculations that we have done. Just double check them.
Sir, I'm not sure if everybody else is, but I'm not seeing your screen. All I'm seeing is your email address.
Email. So I've stopped sharing. But once I came out a while ago, it's probably 15 now. Sure. Are you seeing it now?
Yes, sir.
All right. Yeah, thanks. All right. Yeah, but I'm not seeing Zoom now, right? So I have this up fully. I'm not seeing anything else except the page that down. I'm not even seeing the Zoom. All right. So I
So
just,
just a second on that one, sir.
pardon me?
So just a second on this working out. So you have both -80 and -60. And it said that anti-clockwise is positive.
Yes. Yes, decided. So I'm just taking the calculation. That's all I'm doing now to see if when we had done the calculation, if we had worked out everything.
Everything there would be negative because all these forces are acting in the clockwise position.
Right. So therefore, right. And we had assumed that anti-clockwise is positive. Right. So clockwise is negative. Do you see it? It works. The convention is showing. So if we had chosen clockwise as positive, then we would get it as positive. Correct?
Oh, and you're taking the moments from O, no? O is
Yeah,
not moving.
about O.
Okay, I
Right?
see.
You get what we have done.
Yes, sir.
Right. So now we am going to move on. Right. So I'm just checking. So everything should be good there. All right. So we're gonna move on from that question. So that's question very important. All right. Next one, we're gonna come to more. Let's see which one I should do. I'm going to do this one here. I'm gonna look for it because I want to get the right picture of it. That was in the moment file. Let's go into the moment file and take it out. So the moment tutorial, I think it was in this one. You're probably not seeing the page that I'm gonna open. Look. It was probably a last question. It is, but this question, it says you're to do the reaction. So we're gonna take some more moments. So you're gonna get a chance to consolidate them. All right, good. All right, so here I have it looking much better than what I have up here. I'll go back for those up top. All right. Everybody can see that now? Good to go?
Yes, sir.
Yes,
All right,
sir.
good. All right. I think I'll keep it that way. I can't see person who need to be admitted in there. All right. So we are going to state we are to find the reaction at the points where you have your reaction, right? So we are going to, it says here, calculate then this is what I'm writing. My cap lock is calculate the reaction at A and B, right? Right. Okay, so therefore we are going to, so the first thing you must do, class, you must draw your free body diagram. Let me see if I can. The big advantage is now I cannot see my keyboard. I put the zoom up there. All right, so the first thing you need to do is draw your free body diagram. You never ever start. So you do your F, let's get the block. You must do your FBD. And your FBD means that you must draw a step. All right? That's not the line with a little bit. We need a step of line. All right, good. We have one here. We have one in the center, somewhere in the center, midspan. We call that midspan. And the time midspan of your beam, right in the center, we call it midspan. That midspan, it is 10 kilonewton, and this is 5 kilonewton. And here is 5 kilonewton. All right. Now, at the middle of this is A, middle of this is B. And remember now, right here is a pin joint. Are you seeing? Here's a roller. So here, when you're doing frames, we'll recognize in frame, we'll consider 2 forces here. But for all intent and purpose, what we are doing, we're just gonna do the virtual forces alone. Right? But these examples, just the virtual forces. When you're doing frames, for pin joints, it's going to be a force going that way and one going. But for now, I'm just going to do this one, use this one alone for these type of when the types of reaction we're finding. So that means we ignoring the horizontal force. So we are concentrating only on the vertical forces. Everybody understand what I'm saying? So later on down for these problems, when you see a roller here, it means one force at that point. Pin joint, 2 forces, but that's for later. All right, but I'm telling you now, because you need to know it. All right. So right along here is that beam, right? All right. It wants you to do the reactions, eh? So the very first thing we're gonna use the equilibrium equation. 2 equations that are going to be important here. You have 3 equilibrium equations, but we're not going to use one. This was one that we're not going to use this in this problem. We're only going to use sum of f of y equal to 0, and we're going to use sum of m around any point, whether we use A or B. I choose the right way. So therefore, I'm going to use these 2 right now to solve that problem. So let us start with f of y. And the convention I'm going to use up as positive for 0. So we're going to sum the forces, we write that, right properly. Convention is not proper. Convention, guys. Positive f of
Vertical
y. Right? Yes. Upwards, positive. Downwards, negative. Use that as a convention. Here, I see in some slide, they're switching it around, but don't do it. Stick to one thing until you understand the two. All right. So I'm going to call this one R. Or some people don't even bother with the R thing. They just call this A, Y.
Sir, why the force acting in y equals 0?
I didn't tell you that. It says these are equilibrium equation 1, 2, and 3. I didn't say anything about the forces. I said the sum of the components of the forces. The sum of the components is equal to 0. That's what we said. I didn't tell you that the force there is 0. That's the equilibrium equations. You need to get used to them. So we're gonna continue write them. So I'm gonna use two of them. 2 and 3 I'm gonna use. I'm not gonna use this one because we're not concentrating on any force, because any reaction force we're not gonna consider those. All right. So anyway, let's go again. Here we go now. Let's go with the first one. So the first one, some of the forces in the Y. What are the forces in the Y? All of these forces. We have 5K, 10, and 5K. So we have forces here. You could probably call this C, D, and E, just a matter of load. All right. All right. So we know we're going to sum all of our forces in the Y. So let's write them. So there are 5. First one coming down, so it's minus. The next one coming down, minus 10. And the other one coming down is minus 5. Those are coming down in the negative direction. Everybody agree? Who don't see that? And then now we have 2 going up in the positive. So we have positive AY plus BY equal to 0. All right? So this is now equation what? 1. And we can simplify it, and it gives us minus 20 plus AY plus BY equal to 0. Right? So that's equation 1 simplified. Now, the fact that you have equation 1, we now need to take moment at some point. And anywhere we take moment, the forces there will be nullified. So I'm going to use blue to indicate that I can take moment anywhere. I'm going to choose to take moment at A. So if I take moment at A, right, we're going to take moment. So I'm going to continue anti-clockwise direction as positive. And I'm summing the moment about, I think the blue is a little bit, let me put it back to black. Black is seen properly. So I'm taking moment, but I should indicate where I'm taking the moment about this point. But you see that? But I'm going to write with the black. All right, so I'm taking the moment about A. So put A beside it. All right, so let's go. Equal to 0. And then I'm going to write it. So a semicolon, and then I'm going to start writing. So let's take moment now. All right, so we're going to take our time as far as I can make sure that you can see the page. All right, so the first one, anywhere you take moment, that force at that point is nullified. It's not in the problem. Anybody understand what I just said? So the first one that the first force that I'm going to look at is the 5 at C. 5 at C. What are the distances? Let me put in the distances so that we are clear with them. So the distance between this point is, so you need them. This is 2. This is 2. This is 2. This is 2. So let's do it now. So we're going to start right out at C. Now, we say that anything that turns the body in the anti-clockwise is positive. So the 5 is turning it about O, right? The 5, it's turning it's coming down that way, and it's turning about, the distance from O is 2. So I see moment there, but it's gonna turn the body that way, about O, about A. So therefore, the first one is going to be 5 times 2. All right? Anybody have any problem with that one? All right, let me move up this a little bit more so I can see. All right, so that's the first one. Now, AY is not in the problem because that's where we're taking moment. We're gonna move to the 10 kilo Newton force. The 10 kilonewton force is coming down through here, and it's have a distance from A, which is what? 2. Can you see that? So it's going to be turning the body in the clockwise, which is minus 10 times 2. Nobody see that? Who don't see that? If you're not seeing it, and you say quiet enough, can't help you. All right, so we're moving on. Everybody understand? All right, so move
Sorry,
on.
excuse me. I was having problems turning on my mic, but why is it 10 times 2 and not 4?
Because you're taking it from A. What's the distance from A to where that force is?
2.
Yes. So that's
But isn't like you didn't like completely like I say ignore the fact that A was there and just take it
no, we are taking it about A. Remember, look at what I write over here. Look, we write out what we're taking it about, because you need to tell me that when you're taking moment, you need to indicate what you're doing. So I write out what is it that I am doing so that you can understand. You see that in green? That is what I do. That is what tells me where I'm taking my moment, so I can understand. So you from that language should understand that you're taking the moment about that point. So let's go again. So now it's the 10 is coming down and it's curving. We have blue still, yeah. So it's curving, you're gonna push the body around. So it's like, listen to me, it's like having a compass and you open the compass out to that point. And if you say, where is it turning? It's gonna push it down because it's coming down. It's like it's gonna have a circular effect. So in other words, it's like an effect like this. So can I get a yellow and show you? I hope I can erase it after it. So it's gonna spin it. It's like we're gonna spin it right around. When you push it down, you push it down with the yellow. You understand what I'm saying? You get what I'm saying there?
Yes, sir.
So it's going to push. It's like if you put a compass at the center where A, right there, it will push it right around A. So if you just open the compass out to 2, right where the force is, and you push the compass and spin it in the clockwise direction, it's gonna spin it into a circular point. All right. So that's exactly what I'm saying there. All right. Let's go back to our blue. All right. Let's take the next point. So that is at point D. Let's move to B now, where we have what? BY. Question I want to ask you, from A to BY, what's the distance? Can somebody tell me?
6.
No.
4.
So it is this distance here. Let me show you again. That distance. Everybody see that? But where is it going? Where the force going this time? It's going up. You see that? So it's the same principle. If you open your compass out to this point,
So that would be a clockwise movement.
yes, so it's going to push the body up.
Sir, why couldn't it be anti-clockwise?
What,
From B, why couldn't the force BY be going anti-clockwise?
Because you have to look for the direction where the force pushing the body about the. So first of all, if you put your compass there, open it out to AB, but you're pushing it up because the force is pushing it up, positive up in the air. So consider you open your finger. Let's say your big thumb, put your big thumb at A and spin it and spans it out to B. Like, you remember, you say you guys don't know anything about spancing. First time people used to play marble. And when the marble them lick up at a certain point or whatever, then you used to do a spancing and then open them and out to it. But you guys don't know those games. So anyway,
Sir,
it's the same thing like a compass. It's the same thing like a compass. So you open your compass from, put your compass point at A and open out the marking point at B. But the force is going up. So if you push the force at B, you're gonna push it up. Nowhere more but up in this direction. You're gonna put it up there. You're gonna push it that way. That's the way you're gonna push it positive up. So you're going to spin it and give you a circular effect. Right? It's gonna give you a circular effect. All you have to do is just think of a compass and spinning a compass from that point. Right? It's not hard.
But sir, isn't that anti-clockwise? Because if you look in the
Yes,
direction
that is
of
anti-clockwise.
But sir,
That is
that's what I was saying.
anti-clockwise.
That's what she was saying, but you were saying that's the clockwise direction.
Oh, sorry. I'm sorry if I was saying the wrong thing. I do apologize sincerely.
Sir, don't take it easy,
Let
sir.
me repeat myself. So
Okay, sir.
the
All
force is
right.
going up. Oh, okay, okay. So the force is going up. Let's get that. This if I am confusing. So that's going up and that is going in the anti-clockwise direction. Clockwise is opposite. So therefore, this force is going to be positive. Right? Okay, okay. So I was saying something incorrect. Yes, yes. Thank you for that. All right. So there you open it out from A to B, and you're spinning the force, so it's spinning it up. Well, at least I was doing the right thing, but probably just what I was saying, I was incorrect. But all right. So it's spinning up. So let's write that one. Let's get back with the blue. I'm gonna write. So therefore, that one is going to be now plus by times 4, because that's your distance. All right, we have one more to go, and it's a 5 kilo at the end. Where's E? What's the distance from A to E?
6.
6. So therefore, and where's the force pushing it? Clockwise
Negative,
or anti-clockwise?
clockwise. Negative, clockwise.
It's pushing it
Clockwise.
clockwise. So therefore, it's pushing it down. You're gonna spin it
Negative.
in the clockwise direction. So therefore, we're gonna put minus here because it's minus for clockwise is minus, and it's 5 times 6 equals to 0. Everybody good with that? Who don't good with that? All right. So let's write it now. So this is 10 minus 20 plus by 4by. I want to write it neat. Because you need to 4by minus, nothing wrong if you call it RBY, because a reaction flow. Nothing wrong. Minus what was the last one? 30 equals to 0. So from this you can find by. Do you agree? This is now equation what? This is now equation 2. So it's simplify and it gives you, if we simplify, what are we gonna get? We're gonna get what? Minus 10 and that's 40. So we're gonna get minus 40 plus 4by equal to 0. Who don't follow?
Sir, where you say 10 minus 20 give you minus 40?
Everything. The 10, positive 10, minus 20, minus 30, that gives you minus 40. Is that all right now?
Yeah.
Okay. Okay. I'm
Yes,
just
sir.
working out the numerical value. Sorry, I'm just working out the numerical value. Right? You have a minus and a minus give you a minus 50. Minus 50 plus positive 10 must give you minus 40. We call that what now? You have what? Directed numbers, eh? Something like that. So it's positive 10 minus 50. So therefore, the one that has a greater value must carry it, and that is 40. Directed numbers, all right? All right, so let's go again. All right, so here now we can transpose for by. So 4by is equals to 40. Carry it over. And therefore, we transpose divide both sides by 4. We are getting from this now that by is equals to 10 Newton. It was a kilonewtons. I'm trying to remember what is the problem. Kilonewton. So that is kilonewton.
Sir, go back up at top like a bit when me get a screenshot of this.
Kilonewton. Can you see that this zoom link, this zoom thing is shadowing me? Can't see. We're here.
Yeah, go back down now, sir. Let me screenshot the last part.
I could send this to you.
Yeah, I send it.
But it's all right. I could send it to you. But it's all right. Or I could send you the video. I'll probably send you the video. Right? I'll give you the link in the group. All right. All right. So that's one. So now that we have found by, we know to substitute by in equation 1. So you're going to right now, but we're not finished. So we're gonna substitute equation, no, not equation, value, sorry. by in equation 1. Right? All right. And what is equation 1? Let's see. Equation 1 is minus 20. Wow. How's this thing doing this now? Here, 27. Mute your thing, please.
I think he says that your background.
Could somebody mute their thing? I'm here in the background. If you're watching TV, you're not supposed to be in this class. Right? You cannot do that. That's disrespect to the other student. Right? And they are not concentrating if you're doing that. All right, so let's move on. So we're going to put by in equation 1, and I'm going to write equation 1 again. Minus 20 plus ay. Did I give a 2? All right, and then we're going to substitute by in this. So that's minus 20 plus ay, and we're now putting in by value, which is going to be 10 equals 0. And you're just simply going to transpose. So it's going to be ay, and it equals to, this becomes as minus 10, this come over as plus 20. So that value
Only
10.
10, sir.
Right? So you see that come over as minus. Remember, you taught the simple equations. You didn't know you're going to use them, eh? So you're using them now. Because students normally challenge me a lot of stuff that I teach them that they never use them. But see, you will stuff from basics. So we scaffolding you by just the theory right here. Right? So you're using it to transform you from one level to the other. Scaffold you. All right. All right. So let's move on right there. So that's, you have the solution. So that's 2 problems that we have done. We have 2 more to go. I am going to take this problem here first. I don't have a bigger picture of it. I'd have to go and search for it. I don't have the time for it. No. I'm just gonna expand this one. Let's put it somewhere here. Let's see if I can expand it. It's looking shady. I hope I can read the value. All right. I've changed the value a little bit from the one that I have on the test. Why? Because just in case I have to open up the test, you know, I change the value. So I'm using 100 pound. The one you have is 50. All right. So here now you have a problem. It says A, B, C, and you have D, E. Now, the first thing you need to do, and this comes from the equilibrium section that we have done for forces, right? So the first thing you need to do, you need to draw your FBD. What is your FBD, please? Can somebody tell me? What is your FBD? Can
Free body diagram,
Free
sir.
body
Right.
diagram.
So you're gonna draw your free body diagram. So we're gonna come and we're gonna go that way. I hope I draw it right. And then it comes down that. So we're gonna draw my FBD and label it. So we know what we're doing. So this is D. And I'm taking off the section with E first. So I'm gonna resolve forces about E. And this point would have been B, right? And then, so I'm gonna consider that my force is here, my force is going that way. So you could choose to call it whatever you want to call it. You want to call it, some people probably call it TBE or EB. since that it is going up, we could call it that here. We could label it T E B. Now this one could be called T E B, right? And then now you have the weight coming down here. That nice bucket. And that bucket, they tell you that the weight of the bucket mg coming down is what? 100. That's all. All right, that's the weight of it. Coming down. Mg. My mg is 100 pounds based on what I am seeing in the problem. All right. Now, all right. So it says the tension, not it says determine the maximum weight of the bucket that the wire system can support so that no single wire develops a tension exceeding that. So, all right. So that is what it is. All right. What are the angles now? Let's put those in because those are crucial. We haven't done that.
So we are solving the tension in TEB and TED.
Yes.
Okay.
We already know this one. This one is 100 going down. All right. So we need to draw where the horizontal. I will draw where the vertical coming from. So this is your Y. This is your X. So what have they given you? They said that this is 30. And they tell you that this is 453 triangle over here. Right? They give you a 453 triangle here. So this is 4, 3, 5. What are those angles? Same thing like we did before. If you want to call it alpha, this is 4, this is 3, this is 5. The sine theta is going to go at 4.5, which around, and cos, no, sorry, alpha. I'm calling alpha and then writing something. It is equals to 4.5. All right, so we have those. All right. So we're just going to work with the ratios. We could work out the angles too, you know, guys. That angle we could work. I know one is 30 something and one is 153 something. But we could choose to work out the angle. We could work out the angle here and use the angle. If you want to do it that way, let me show you. Find one of them for me. Any one of them is going to be same value. So sine of, let me just show you the two ways. Easy. Sine of 4.5 is how much again, guys? 0.8. So sine inverse of 0.8. It gives you 53.1. So we are saying if you choose to work it out, this is 53.1. So that means alpha sine inverse of 4.5 is equal to 53.1. They could choose to put in.
Sir, why we didn't use the weight to in the 3, 4, 5 triangle?
You can't use the weight in the 3, 4, 5 triangle. It's only 3, 4, 5 triangle is only giving you a direction for the tension in TEB. That's all it's doing.
Okay. All right, sir.
Yeah, man. All it's doing is giving you that. So therefore, we know that this angle is 53. For those persons who are not comfortable using the ratio, I just showing you two ways. So now that I have the angle, I can just work with the angle straight. All right, so I have angle over here, angle over there. If you're comfortable with that, do that. All right, so let's write them now. So sum up the forces in the y equal to 0. And you're taking y as positive going up. All right, so if you look for your forces in your y, what are the components you have? A component going up in that way. All right, and you have one. So one coming this way, let's do it in blue. Two of them. One coming that way, and one going up that way. Can you see that? One going that way, and one going there. Likewise, over here, one coming that way, and one going that way. All right. So we need to identify the horizontal and vertical component. But we're gonna do the horizontal one time. So let's write them. I'm gonna write it in black. So for the vertical components, it's going to be for the TEB, So it's going to be T E B. And the force is going up is what? Sine theta, right? So it's sine, the theta there is, we know the value of the theta. Let's put it in. So it's sine of, what's the value there? 53.1. And it's positive. Do you agree with that? That's for the Y. Oh, that's one in the blue. All right, the one in the green now. This one is going to be what? T E D sine of the 30 going up. And it's both positive. There's T E D sine 30. All right. And then the other one is going down, so it's minus the weight, which is what? Mg equals 0. And you have the value for that. So you can put them in. What is sine of 53.1? And cos of this one?
Excuse me, sir. I have a question.
Mhm.
Why did you put mg is equal to 0? Because I thought you'd put negative 100.
If I put, it's what? It's positive 100. I put, yeah, you could put that in too. You can put it in. That's all right. I choose to put the symbol in just to that's all right. So sine 53 was what? Point 5, point 8, sorry. So we could work out this one. It becomes 0.8 TeB plus sine of 30 is 0.5 TeB minus 100 equal to 0. So your equation 1 there, the 1. Who have a problem with that? Any problem there? Who don't see how that go? Next one. The sum of the forces in the x equal to 0. Taking that direction as positive. All right. Hang on a second, guys. I'm gonna go for some water. Sorry. 1 second. I like this. I'm right. 1 second. Get some. All right. I hope everybody's understanding so far. I gotta speak for it a while. All right. So let's go again. So now that we have done that, we are going to concentrate on all the horizontal forces. So the horizontal force down here for the TEB is, but this is negative, but you don't write it, you just give the direction. And that's all right. EB, sorry. Okay, going from E to B, up the force is acting in that way. And then this is cos of that angle, 53.1. For the green one, over TED, it's going to be TED cos 30. Anybody need any clarity right there? Body good? Are we good there?
Sorry, you say you don't write the negative for the TEB cos 53.1?
No, you don't write it because you already show the convention there. You just put the force there. When you're writing, you put the negative. Do not put any negative when you're doing upon your free body diagram. When you're writing the formula, you can put it in. So here we go now. So for this one, let's write the TEB first. So that's minus TEB as in boy cos 53 pounds. All right. Plus T EB cos 30 equals to 0. Right? Everything good there? That's now equation 2. Let's simplify equation. Cos of 53 is what it again. Cos of 53.1 is 0.6. So this is minus 0.6 T E D plus T E D. All right. What is cos of 30? Cos of 30 is 0.866. So let's hold on. Let me erase that and rewrite it. So we're gonna put the letter, the numbers before the letter. So 0.866. T. Some persons things were weak. It's in and home. All right. So I just label the one that is simple. Those are equation 1 and 2. So we need to decide now, how do we solve these equations? All right. Now, clearly, you could make one subject and substitute in the other. So anyone that looks simpler, I'm gonna go with equation 2. So equation 2, I'm gonna simplify it, and I'm gonna put 0.866 T E D equals to 0.6 T E D. All right. And for that, I am going to make don't make any one of them, Mr. I'm gonna use gonna transpose for T E D. It was D, right? Yeah, T E D over this side here. I'm gonna make it equals to 0.6 T E D divided by 0.866. All right, when that simplifies, let's see what I'm going to get in here. 0.866. Is that right? Another question. I'm looking for figures that will help my purpose, make the problem a little bit. So when you're doing this section, be mindful that whatever you choose, you want it to be simple. I'm not gonna use that. Let's transpose for EEB. It's a little bit simpler. You want a whole number if possible. I'm trying to get a whole number. So it's T E B will equals to 0.866 E E B. So those are the strategies, guys. You want to try and get a better spot. If you could get a whole number, it will make the process a little bit simpler mathematically. So this is what 1.44. Yeah. So this is what more like a so this will give me 1.443 if you choose to keep so much point. So you don't get a final answer yet. All right. So therefore, you have simplified this, and this is now equation 3. TEB is equal to 1.443 TEB. All right. That now, you're going to substitute equation 3 in equation 1. All right. So then now you're going to substitute. What is happening in the right now? Come on, be yourself. Equation 3 in equation 1. Remember what was equation 1? So now let's write back equation 1, and we're gonna drop it in. Anywhere This is in equation 1, I'm gonna drop it. It says 0.8, open bracket, TEB is equals to 1.442 TEB, close bracket, plus 0.5 TEB minus 1. We don't follow so far. Very good so far.
Yes, sir.
Following. Everybody comfortable? So now we're going to expand that now. So that is going to multiply by 0.8. And then we simplify the first part of that expression. We're going to get
Sir,
1. Yes.
people are saying that they don't understand.
So, all right, before I go
So
on,
is there an easier way as to how to solve this question, sir? Because
all right.
this method is quite long.
So what you end up with, let me just explain. What you end up here with is two equations. First, equation 1 and equation 2. And you could go the root and say you have two equations. You're gonna find you have two equations with both EB and ED in it. So some people would say simultaneous, but I'll tell you use a substitution method. So we just choose one of the equation and you're gonna transpose one of the items. In this case, I choose, you could use anyone, you know. I choose to use EB because when I'm using EB, I get a whole number with this, which makes life easier in the substitution process, rather than having the decimal. So if you can avoid the decimal, you work with whole numbers. It makes life easier mathematically. And that's the only difference why I'd switch a while ago. Because when I divided 0.6 by 0.866, I'm getting another decimal. So I couldn't work with that. I prefer to do it the whole number. So that's why I switch and substitute EB, because what I'm going to do now is get an expression with only EB in it that I can solve for. Does that help? Do you need more clarity? Why I did that process? Does that help? Hello? Can somebody talk to me? I like you guys talk to me.
Yes, sir. It
So
helps.
plus 0.5. So I'm going to finish right out. So that you work out the first part. Getting all numbers in your equation is make life easy. Yeah. All right? Minus
Sir,
100 equal to 0. So
sir, it should be 1.154.
pardon me?
It should be 1.154.
For which one of them?
The 0.8
Times that.
bracket
Let me go.
1.453.
0.8 times 1.443. Oh yeah. Yeah. So there's a one missing there. One. Yeah. Thank you for that. So there's a one missing. Yeah. So there's a one here. Would have worked it wrong because there's a one missing. All right. So for this now, if you notice, look carefully now what's the result. So as a result, I have everything in ED. Everything in ED, that is the objective of using. So rather than using a at school, they use to teach a simultaneous equation. Not true, right? But you can also solve simultaneous equation by substitution. And it is a preferred way to do this problem. Because if you use elimination, you are going to sit down there, go choose numbers to multiply by and do that long drawn out thing, use substitution. Right? So remember, you have various ways to do simultaneous equation. You can use various ways, but you can use elimination, substitution. You can use graph, blah blah blah. But this is my preferred way. All right. All right. So let's continue. Let's us continue. Where is my mouse? I think we're all right. All right. Let's slide up and finish the problem. So now you're gonna add all the, so everything you get with TED, you're gonna add it. So you got 1.154 plus 0.5. So you'll simply work out to having 1 point, oops, let's write with block. 1.654. That's what you have there. TED. You can take this over and it becomes positive 100. And remember it was in pound, right?
Sir, please send this in the group when I finish, sir.
And then you finish, don't worry, man. And then I will probably send you the video. Don't worry. All right. So then now when you transpose for this, you will get TED equals to 100. Come on again, this right again. Start. Anytime I touch this button here, it's starting to do all different nonsense. Give me a second. All right. Let's do that. And then, all right. So let's go again. So then you have 100 upon 1.654, which is equals now. Remember, it was in pound. You hear? The answer is going to be in pound. So that, I'm going to find the inverse of that and going to multiply it by 100. So I'm getting 60.4 pounds. Right? And I'm getting it as, right, just 60.4 pounds. The fact that
Wait,
you have
sir,
that now,
excuse me, sir, could you explain how you got the 60.41 pounds?
yeah, because I divide the 100 by the 1.654. You transpose for TED. Take
But
TED out of the formula, you divide both sides of the equation by 1.65. So if you do the left, whatever you do to the left, you must go to the right. I kind of jump away from that step because I have an expectation that my students will kind of not need to there are some steps that I'm not going to go right through it, and you have to appreciate that
oh
because
no, sir, I understand it now. I just divided it wrong. That's why. Understand.
that is
You don't have
all
to
I'm
do
saying.
all of that now.
Yeah, because I can't keep on doing those baby steps. We won't finish. All right. So, all right. So I put that in. All right. So now that you have the 60 pound, you can now substitute. So you're going to substitute TED equal to 60 and 4 in back into equation 3. Because remember, you formulated an equation 3. So equation 3 said, trying to see, let's copy. When I bring it down, when I bring equation 3 down, this is a good way to do it. All right. So this was it. All right. So here we have it. So that's equation 3. And we're going to just substitute TED in. It's simplified. So it's simplified and it was TED is equal 1.443 TED. All right. So in that case, TEB is equal 1.443 open bracket and you drop that in, which is going to be what? 60.4. So what that gives you, multiply that by 1.444. And guys, you can help me work here. I will make the smooth out the process. I don't make me have to go to the calculator every time. I will take your answer if I can hear 2 or 3 persons telling me the answer.
87.17.
87.22 I got because I'm using some decimal points. How much you got? 1. I'm using extra decimal points to make sure that I bring the answer to the more very accurate point. All right. They could
Sir,
use
I got 87.15. No,
Because
87.16.
maybe you didn't. I use extra decimal points. So that's
Oh,
why my
okay.
answer is that.
Okay.
All right. You can double check it still. All right. But anyway, that's not anything bad. It just means that you use less. Probably you use 1.44 for TED or whatever. Remember, I have 3 there. And whatever. What did you substitute up here? 60.4 are you using? What
Sir,
did you?
I use 60.4.
Okay. And the same thing, we can't substitute the same thing and get different answer. That unless my calculator not working or yours. All right.
Well, I'm using a Casio, so
Pardon me?
I'm using a Casio, but I got 87.16.
Hang on a second for me, guys. I think something here. Sorry, everything. So, let me see what is on my calculator. Oh, you're right. I get it. I redo it and I get a different value. All right. All right. Thanks for that. So it's stuff like that I want. That's all right with me. Once it, yeah, because so whatever reason we can get different values. So I'm confirming 1.6. And if you were to give me 3 significant figure, 1 decimal point, you'll get 87 point. All right. So you could actually have it, the answers 87.2 pounds. Good with that? All right.
Yes,
So there
sir.
now. So right there now, we have found, if we go back to our problem, we find the value for TEB and TED, right? So we have done one segment of the problem. The next part is we're gonna go again. So we have done that section. We need to do, let's bring this down. We're gonna pop it
Excuse me,
down.
sir.
Let's bring it down.
Sir, before we move on, right?
Yeah, bring the
I
figure down.
understand.
And
Understand.
yeah, go ahead, go ahead.
I understand everything, right? But you
Yes.
drew the free body diagram.
You don't understand the free body diagram?
No, I understood everything you did, but
Mm-hmm.
the free body diagram that you did, right?
Mm-hmm.
That only has TEB and TED, right?
Yeah, so
What
that's
about
why.
the other rope at the top, the string at the top there? Why do we ignore that?
Which row? So
BC.
now, so we're taking it phase by phase. We're not
Okay.
ignoring them, but we're just taking phase 1, phase 2.
Cool.
So part 2 now, I brought the solution here. Probably I should make it a little bit smaller because it's in my way. Hang on. I'm trying to, so this is my favorite page to work with. Over the years I've used this page. And I find it very useful. So I don't bother with it. I know that Google have a right here. I don't mess with it. I have a better right. All right. So now we need to draw back a free. We saw part 2 of the problem. And then we need to go and draw a free body diagram again for part 2. So here we go. So we have a part goes straight. Right? Right. So this is A. This is B. Right? Then we have another part goes up to C. And then you have another one going up. So, right here. Right. Some person's internet seems to be very unstable. All right. So this part was what? E. Right. Now, the fact of the matter is that we work out some already. We have that already. Right. And we have that. Yeah. Yeah. So we have pretty much some angles here. We had worked out some already. We know that this is, let's put them in. That's us 30. We had worked out EB. You remember we had worked out EB? What was EB? Let's show it up here. EB was 53.1 down here. Let's draw it in where it was. So right along here, down here was, this angle was 53.1. Everybody remember that? That's important to me. So I have this angle down here. Oops, I want to use a different color. That's not a part of my feeder. The angle. This angle here is 53.1. And let me put in the labels. So this is T, E, B. And you notice the direction of where I choose to put the forces. I'm putting them in the direction that I have them labeled. And this is T, B, A. Right. So it's any direction I choose the force going, that's the direction. This is the rigid body. That's the direction that I'm putting the and labeling with the labeling, which as consistent as possible. And this is important. So therefore, this angle here is 53. I'm writing a different color for clarity. This angle here so is also 53.1. Right here. So to the horizontal. Can you see that? So right here now you can see how alternative force comes in. Is that diagram too small? You want it bigger? Or to make it a little bit bigger, right? Peeling it out. I'll have to do some adjustments. Let's get it a little bit bigger. All right. So here's the angle there. That angle is 53. So this is T, B, B, right? And the arrow is going up. All right. So there we have it. Now that you have three, but we have one force. What was TEB again? TEB is 87.21. 87.2 pounds. Right? Agree?
Yes, sir.
All right, good. So now that we have that, we only have two unknowns. So we don't have three unknowns. Right? That's all you're expected to do. Follow the principle and work the problem. So you're gonna do the same thing again, repeat the same process. We'll start with X this time. Some of the forces in the X equals to 0. So let's look for them. All right, the first thing we need to do though, we need to reckon what's our component of our forces. So we have for TBC, we have some forces here. Wow. So this is T. The first one is TBC for the virtual sine 30. That's what I'm going to. The horizontal one, so that is our the Y component. For the X is going to be TBC cos 30. And you notice I'm not putting any sign, I'm just telling you what they are. All right, so that is important. And we already know TEB, we can find that one. You have one coming down. Let's write those so we can just work with them smoothly. We have one coming down. And we also have one going that way. Let me do it with a different color.
So sir.
Something gone. Okay.
Sir, when you say work it out in phases, you mean just choose two strings at a time and then
Well, it's three. So look, let me go back again.
yeah.
Let's scroll up onto it. When you say in phases, all I'm saying is we're gonna take one segment and work it first.
Right.
And then when you finish, you know that the BE string is going to be interlocking to the second phase with a value.
Yeah.
Right? It's going to interlock there, so you have to consider it. So yeah, so you're taking a section first, and then you're doing the very same thing. So let's find the component of ED again. One is coming down, and one is going that way. So they are both negative components. Let's find them. Let's write them now. Yeah. So one is T EB for the
Sir,
X is going to be what? Pause.
sir,
Pause 53.1. One on. For the
sir,
Y, it's T E coming. TEB sine 53.1. Those are the components that we are working with. All right. So again, yeah.
Sir, for TEB, you put the force up, sir. But then you're saying it's going down and left.
What is still going down and left? What did we
Sir,
assume up here? What when we're doing this part up here, what did we assume? Did we assume that it's going up here, so? You see it right here? What
yes,
did we
sir.
assume? So we keep the same assumption.
The force is going up.
Right. Wherever assumption you made in the last part, you have to keep it.
But sir, you're saying down the bottom that it's going down now.
What? I didn't say, did I change the position?
Yes, sir. He's right. He's right. That TEB here in in this equation is going down. It's supposed to be going up.
Where? Let me
The
see.
blue triangle, the blue arrow,
The blue arrow.
the vertical one. It's supposed
Oh,
to be going up.
yes. Thank you very much, sir. I didn't even. Oh, yeah. Oh, okay. That's what you're saying. Oh, yeah, right. So, yeah, because let me look and see. Let me check. Because you're going that way in the blue. Let me put back the blue. If you're going up, then you're going to be going that way, and you're going that. So you go that way to go. Oh, okay. That's what you're saying. Thank you, sir. That is what kind of interaction I like. Yes, that's what I want. I don't want to come here and sit and look. That's it. Yes, so that is correct, sir. So that means I have one positive and one negative then, correct? But as I tell you, I'm not putting in any, when you're doing a drawing, you only draw the conventions in, and then when you're actually doing the resolution, of course, you start writing your case. All right, so let's do the first one now. Now that I have, let me clear away this, this is probably gonna be in my way. Make it a little bit smaller. All right, so let's write them now. So we're gonna do all the x's first. So one we have that we don't speak about is equation one is going to be TBA. It's minus, don't assume that it's minus because it's going in the negative y direction. Remember our frame of reference is x and y always. And then we have for TEB, we have one going in the negative. What's that one? Minus, what value is that again? The x is TEB cos 53.1. Agree? All right. And then for the TBC, it's positive plus TBC cos 30 equals 0. Good so far? Body good with that?
Yes, sir.
All right. And that's equation 1. And then equation 2 now. Let's write equation 2. Let's bring that down a little bit more so you can all see. Right. Equation 2, I'm gonna write it green. All right, I hope you can see it. I prefer black doing. But because I want to kind of, all right, I'm gonna write it black. I like it. Black is better. Probably hurting your eye, I'm not. All right, I'm not gonna write it with me. All right, I'm drawing green, but I should really write in the black. All right, so I'll write in the black. So therefore, we're gonna do equation 2 now, and we're gonna sum all of the forces in the y equal to 0. All right, so let's start. So we have one going home. This T BC sine 30. All right. And we have another one going up, which is going to be plus TEB what did I tell you happens? That's sine again. Sine 53.1. Am I correct here? Let me just check that. Yeah, so that's a sine. All right. Everybody see those forces? Do we have any more? Do we have any more forces? Go invert what?
No, sir, because the TBA is going to be zero.
Right.
No, sir.
All right. So we have, and they are both positive for the y. And those are sine, and the other ones are cos. So we're looking, how many forces we have for the cos here? We have 3 for the first one. So this is now equation what? 2. So equation 2. So let's simplify them. Equation 2. All right. So I'm gonna call on to you for the simplification. All right. So what's the first one? Cos of 53.1. What is that? Cos of 53.1. What is that? Give me a value, please. I'm not going to the calculator.
Sir, it's 0.6.
0.6.
You said 53.1, right?
53.1 cos.
Yes, sir. 0.6.
All right, good. Plus the other one is what now? 0.866. Is that what is that? Cos 30 is what? 0.866? What's that?
Yes, sir.
All right, I'm not going to the calculator. You guys gonna do it. All right, so that we have 3 unknown in equation 1. You recognize that? So simplifying equation 1. This is EQ1. And this is EQ2. All right. Next one. So we're gonna work with equation 2. Let's simplify this. So equation 2 now simplify is 0.5 TBC plus sine 53.1. How much is that? Sine 53.1.
0.79.
79.
0.79. Have any more decimal point?
Well, it's 0.7. Well, it's basically 0.8 actually if you round it properly. Because
That's what? Sine 53.1.
yes, sir. It's actually 0.8 if you round
All
it.
right, 0.8. Let's call it 0.8 because of it. Where's my writers? Come. Let me clean myself. And this is T B B equal to 0. So now I am going to, this is equation 2, of course. Equation this is 1 or 2. This is 2. So this is equation 2. Now we're going to write equation 3 because we're going to transpose one of the equations for the other. So I'm going to choose to use equation 2 to form equation 3. So we're going to transpose. So we're going to say, all right, so I'm going to find T. But no, hold on. We don't need to do that. Don't we have one of these values already? Don't we have TE? Which one of the values we have? TEB, don't? Couldn't you guys remind me I have TEB? So TEB
was 87.2.
pounds. So we're good then. So we're sailing then. Different thing now. Fact that we have this value, we are going to substitute this value. So we're gonna substitute that value in equation 2. Right, cool. So we're moving faster now. So this value is gonna go in this equation. So let's do the substitution. It's 0.5 TBC. So we can find TBC. But there's only one unknown we have in this one. And then we put in 87.2 equal to 0. All right. Beautiful. All right. So from this we get 0.5 TBC equals what I work out to be
69.76.
87.2. How much you get it? 69.
0.76.
76. Check that again. Sure.
Yes, is 0.8.
69.77.
Hold on. I'm gonna rewrite that. You give me the value.
So I'm using the values that you have written that
16,
you're presenting right now.
69.7. How much?
6.
I'm getting 72. Why am I getting a different value from you?
Sir, I'm using the values that you're presenting right now.
Oh, okay. All right. So I'll work with that. Give me another decimal point now.
69.76.
All right. Cool. So here, because we don't reach a final answer yet, so you must always, use 4.
Sir, change the sign, sir.
Pardon
The
me?
negative.
Oh,
The,
thank you, sir. It comes over, so it must be minus. Thank you. 0.5. What's that value? Guys, divide that by 0.5.
Negative 139.52.
All right. So negative 139.5 would suffice. Pound as final answer. All right. So negative 139.5 pound would suffice. All right. And then you're just going to simply now, so you have two of the unknowns. So you're just going to drop it in and find the last one. So you're going to substitute. So here you go. You're going to substitute TBC minus 139.5 pound and T EB 87.2 pound at in equation 1. All right, so let's bring equation 1 down. All right, that again, I'm just gonna bring them down. The simplicity. Let's drop it. I'm gonna bring them. Drop them right here. So we have our expression right here. Good. So we're just gonna substitute. So only one thing that we don't know is TBA. The minus TBA minus 0.6 times PE 87.2 plus 0.866 minus 139.5 equal to 0. All right. So we need to just solve for TBA, not true. So can somebody multiply out this summing? 0.6 times 87.2.
52.32.
52.32.
32.
All right. Plus next one. This one is gonna be a minus though. Let me just correct that. Point 866 times that value.
Sir, it's 120.807.
120.
0.807.
All right, equal to 0. All right, guys. So we just need to simply transpose that now. So you could say that TBA is equals to add these two for me minus 52.32 and minus 120. So you should be getting something like minus 172 72 or 73.
73, sir.
73 what?
0.127.
All right. So that's the process, guys. You have to be consistent.
Wait, sir, I don't think you're finished because it's a negative TBA. So when you divide by -1 on both sides.
No, what I did, because there's an equal sign here at 0, I just take it over the other side. You get what I'm saying?
Yeah, but sir,
Follow, you
even
notice that I
when
have it as positive. So, all right, let me just show you what I've done. What I've done. Wow, why did we do that? Trying to use this technology here. What to come down. Everything must move. So what I'm simply doing here. Come on, wait. That is fine. This is minus, so I just carry it over the equal sign. Rather than writing another line, this is, remember, this is 0. So if you carry that over the 0 side, you're still left with this minus. You get me? Rather than
Sorry, you still
working out.
write negative.
So what I'm doing, I hold this side and I just carry this now. Because
okay, I see now,
yes,
sir.
I just come on right now. I just carry that over the 0. The do I just carry over the 0, but I only do. You got me? So
Yes,
in
sir, I
other words,
understand.
you could write, if I was to write a long way, I would just go what now? I would have to go minus TBA equals to 50 yeah, I think for the last question I'm gonna take a 5 minutes break and then proceed. 120.8. Right? And then now I would divide 2 by -1. Whatever I get here, I divide 2 by -1 and get this answer here. Oh, let me get it. Then I just do this. I try to copy it out. Oh, it didn't move it. I want it to move it. Come on. Let me know. So I'm gonna take a 5 minute break because we have one more question to do. I want it to move it. Is it giving me an option? No. Not giving me an option. I can copy it. There's a copy, but it's not moving. I can erase it. All right, so I need to take a 5 minute gap. And then so that would have been the process of so that is the long way. Carry those over the negative over to the 0, they become positive. But then now you have to multiply 2 by either multiply 2 by -1 or divide 2 by -1. The same thing. But you have to remember, you have to what? You have to sum these first. Come on. You have to sum everything up there first before you do anything. Guys, remember, sum these first. To get the 172. You cannot divide through, you must add before you divide. Those rules that you're taught. Right? So if you divide 2 by 53.1 and then add it to 120, you'll have get a 1. You must sum before you divide. All right? Your numerator. All right. All right. So we're gonna take we have one more question to do. A little bit long. We're gonna take a 5 minute. I need it. Where is it? So I've done those, and then we are doing this guy. I have this guy to do. I'm gonna take this guy down the bottom here, cutting, dropping all the way down. Oh, this is the one that we're doing. You guys can start working. I'll leave it up, but I need a, and I was 8 o'clock, I need a 5 minutes break before I finish this one. 5 or 10 minutes break. So I'll give everybody, you can all take your water break and I think that's what somebody else is coming. Somebody talking in the chat. When you're in the guys, when you type in the chat, I will not know because I'm not going to be looking in the chat while working the problem. So if you want to say something, open your mic and talk. That's the fastest we do. All right, so this is the last one to do. I want to explain it properly, so I'm going to take a 10 minutes. I'm going to make it 10 minutes. So we get back. I'll stay, make it stay. We will resume at 8:20. Hopefully we'll finish by about just minutes to 9, we'll finish. So this is the last problem. All we need to do, everybody, work out the components first. So when I come, you can easily tell me how to solve this problem. It says two couples act on the cantilever beam shown. If F is equals to 6, determine the resultant couple. There is also resultant couple here. So both of them resultant couple. What I suggest, work them out into component first and just get the resultant couple. So this is not hard. We just need to do two sides. We know F is equals to 6 already, and then 1 is 5. So this is not hard. We should finish within 15 minutes. 2 steps, and we finish this problem. So I'm going to take a gap. All right, is that okay with everyone? Hello?
Yes, sir.
All right, so we're going to take
Yes, sir.
resume in another 10 minutes. Someone saying something? Hello? Got it good? All right, so I'm going to pause the video. Please remind me to resume when I start up the video, please. No, I'm not gonna pause here. I'm gonna pause it. Pause recording. All right. I suppose you all finish working this problem now. All right. I suppose you all finish working the problem. Yes or no?
Halfway there.
So you all should be confirming what we're gonna work out now. So this problem is similar to some aspect of it in terms of finding the components. So what I'm gonna do, the 4-3-5 triangle, that one I'm gonna work out for. So first of all, can you see what I'm doing? Am I still sharing?
Yes, sir.
All right. So that is your 5 kilonewton force. And so this is easy because it's basically the same. So we're saying that the angle here, right? We can simply write them in ratios. Technically, let's still work them out. I'll just show it for those starting. So we basically know what's the components. You see the components already. One is 4 and one is 5 kilonewton. But let's work it out for those for clarity. So you say sine alpha is gonna be equals to 4.5. All right, and the angle. And cos alpha is equals to 3.5. All right. So that's what we know. You could choose to work out the angle, or you just use the ratio. It's easier to just use the ratio. All right. So let us do it the long way. So we know that. All right. For coupling, all you need for a coupling is to know one, the distance between the two forces. So you have, so let's draw this. So one is, put this in green. The one is going up, positive. One is going negative for that one. All right, but for this one, so we look for that. All right, that one. And then the other one in blue is coming, one is coming down, and one is coming that way. All right, do you agree with that? That's for that one. For the other one, the F, which is equals to what? 6 kilonewtons. One is going up, right? Let's take that out of this different color. Different color. So this is 6 kilonewton. One is going that way. One is going out. Right? Same thing with this one. But remember now, you don't have to do both forces. You just need to do one and the distance between the forces. Let me see if this is correct. So the one is going that way, negative, and one is coming down. All right? 1 second. 1 second. Give me a second. All right, so let's go. Okay. So all right, so now that we have the components, so what are the components of these sources, please? The components of the 5 kilo, as I already told you, one is going to be 5 times the angle. So let's write them for simplicity. So it is going to be for the, let's write the x first for the 5 kilo. So the x would be 5 times cos of the angle, which is going to be equal to 5 times 0.5, which gives you back what? 3. All right? Everybody said that it is 3 kilonewtons. I already told that it was 3 kilonewtons. And for y, it's 5 times sine alpha. So it's going to be 5 times 4.5. So that's equal to 4. So we know the values already. So we have them. So going up that, going in the x direction, it is 3. Y direction is that. For the F now, let's work them out also for the F. We know them. So for F equals to the 6 kilonewtons, the X component is going to be equals to 6 cos 30, right? And the Y is equals to 6 sine 30. All right. And so we know that for the y, it's really 3 because sine 30 is a half. This one is going to be cos of 30 is what again, guys? Point 866 times 6. So that gives us 5.196. All right, good. So okay. It says to you, you must do the coupling action on the cantilever. If F is 6, just term the resultant couple. All right, so we're gonna do the resultant couple. All right, so we're going to take anticlockwise as positive. All right, I'm running out of space. All right, so we're gonna take anticlockwise as positive. So I'm going to take anticlockwise as a positive. Right. So, all right. So you have, if you notice, before we start analyzing it, there's two 500 forces. And remember, the coupling between it will be equals to the distance between the two forces. So the distance between the 5 kilo vertical components is what? 0.5. No, that's not 0.5. That's 3, sorry. So if you notice, let me see if I can, what can I use to illuminate it? So this is 3. In these 4 points is 3. Do you agree with that? Between between this point,
Yes, sir.
and here is 3. All right, that's what we're concentrating, that force. And then for the other one, can I get a different one now? On a different color. This color over here, I don't have much option. You're getting the distance between this one and here. The distance is what? 1. You see it? Sorry. The distance here is the distance between here and that distance there. It's 1 between them. Whatever component you have here and a component you have, the distance between them is 1. Let's go about that part. Right? All right. So the distance between the components for the virtual ones is here. So it's a components here. So let's do them. Operator. All right. So when I start with the 600, let's start with the 600 force. So the 600 force, all right. The distance between them, we have 6 sine. So let's look the one in the y. So you have the component going up here. Where's the so you have one going up in the y. See here? Same thing here in the blue. That one going up in the y. Right? And this one going up in the, so you have one in the y there. All right. So let's go with it now. So it is 6. So between the two forces, you have 6 sine. Do you see where the 6 sine 30 is? You need to write it in. So the virtual here is 6 sine 30 for the virtual component here. All right. And the virtual component down here is this. Can you see the point? It's between these 2 points here. So it's 6. And we're taking which direction? Which direction are we is it body moving? So is it distance between both of them? One going down, one going up. What's the distance between them? What's the distance between them?
1.
1 meter, sir.
No, man, I'm talking the virtual component of F. The virtual component. What's the distance between the virtual component of it?
3.
Right. So the distance between the virtual component of it is 3. And it's going to be turning the body which direction?
Anti-clockwise. No, yeah, anti-clockwise.
Anti-clockwise. So therefore it is 3 and it is positive. Do you agree with that? So between this component in blue, the virtual components that I marked before, so this one coming down and that one going up. So it's a distance between them, and the distance is this between the two components. So that's the first one I'm right. All right, the next one now, I am going to look at the horizontal component for that force. The horizontal component, where are they? They are in blue still. All right, let me highlight them. One there. And the next one over here. What's the distance between it now? Those distance. Well, let's work it out and total. What did we say it was? 1?
Yes,
Because
sir.
this is midway is a half, midway is a half. So that is 1 between the distance between them. It's not this force we're talking about down here, no. It's really this one down here. But the distance between them. See here? Them run between here. Distance that is span between them is 1. All right. So where is that turning the body now? Is it clockwise or anti-clockwise? Huh? Anybody can tell me? Are you seeing what I'm doing? So we're looking at it here and here. We're gonna take the yellow one. We're gonna work with the yellow. Let me take out the yellow from here. I'm gonna draw it as yellow. That force is turning about this point here. What is the effect? Is it clockwise or anti-clockwise?
Clockwise.
sir.
Pardon me?
It's clockwise.
So therefore it's going to be minus what now? That right I look too big. It's like a marker. Not very, let me see. Says that one times so the component is what now? 6. Oh, I can't work with that. It's not, I can't write with it. I was trying to write it in yellow. Let's put it in black. It's minus 6 cos 30 times 1. Right? And we could put it this way so that persons can understand. Let's open a bracket. 0.5 plus 0.5. Right? So that is for the components for that force. And then now, so we could work that out. Work that out for me, please. So this is 6, that is 6 times sine 30 is 3 as I had it over there. 3 times 3, that's what, 9? Is that so? Minus 6 times cos 30 work out to be 5.196 times 1. All right. So what we have there, please, so that work out to be 3 point,
yeah, 3.8
something.
Just 3.8 because there's a 0 after.
3.8 kilo newtons meter. All right. So that is one part. So that is for the force one. That is which force you call that? The F force. It's also F force. Right? It's the F force. And I put it in bracket because it's not about F force, but it's the coupling moment for the F force what we work. Right? All right, next one. So that is 1. Coupling moment 1 for F equals to 6 kilonewtons. Right? Is it 6 kilonewtons that? Or maybe I should just erase it and put 6 kilonewtons. F equals 6 kilonewtons there. So person can F equals to 6 km. That is too small. Person might not see what I'm writing. Fix up it. So F equals to 6 km for that. So that is the 6 km. That's the first one. So we're gonna take moment again, but this time now we're gonna take the sum of the moment for 2 for the 5 kilonewton force. So all right, so that's a good way to do it. Leave out the symbol and just put the figure. 6 kilonewton. All right. So you can know which force you're taking the moment for. So the moment one is for the 6 kilonewton. We can call it moment one and call it moment. All right. That symbol is all right. Good. All right. So let's do that one now. Let's take up a writer. Let's see what that one gives us. So we're gonna work with the 5 kilo force. All right, so let's look at it again. Take up a yellow. So the 5 kilo force for the virtual, so the virtual 5 kilo is going to be between this one here and this one here. We're gonna just, one of them you're going to use. Anyone you want to use. What's the distance between it? What's the distance?
Sir, you have another color marker. I can say you can see the difference.
Let me see if I can select another one. Yeah, I can select. Yeah, I select.
Sir, I think the
All right,
distance.
so I'm gonna select another one. Hold on. This one right here. I'll work with this one. You see them? Those components I'm gonna work with.
Yes.
All right. I'm also sure I can wipe with that color. Let me see. It might hurt your eyes. If they do have it, yes, I have it, but it will hurt your eye. Let me let me see if orange will work. Orange might not be bad. Similar to what we have. So
It's just to show the difference on the diagram. You can use the black down the bottom.
oh, okay. All right, fine. Let me change the black. Change back to black. All right. I don't like that black. This black just look like it's not going to come about black. All right, cool. All right, that should be all right. Let's go back. So, all right, so for the one going up, what was the component we work out for the Y going up again? It was 4. So we know it's a 4 going up and 4 coming down here. You could choose any one of them you want to, right? And we know the distance. The distance between them, between this point and this point, all right? We already know that anti-clockwise we're choosing for our moment, so we just need to write our force. So any one of them, which way, if you're taking the one that is up top, where is it turning it about this point here? Where is it turning? Is it clockwise or anti-clockwise?
Clockwise.
Clockwise.
Okay. And if you take the bottom one, you get the same thing. Between here and this point here, turning it clockwise. So we already know that this is a minus 4 times, what's the distance? 3.
3.
Do you agree? All right,
Yes.
so that's one. All right, what about the X component now? The X component, where's the X component now? Let's see if I can get a different writer marker for that one. What color can I use? Yeah, all right. This one is a nice one. This is the latest color. The component here. So the next component here. Okay. All right. So what's the distance? Let me highlight the distance a bit. So distance that we're talking about is this distance. Right? Here. The distance there. This distance here and that distance right here. The distance is going to be 1. Do you see that? Can you see that the distance between the components is
Yes,
1?
sir. Yes, sir.
All right. So therefore now, if you take it from, if you any one of them, so any other point them, suppose you want to choose this one that I'm marking right here. And you take the force on the other one. So if you consider that the one below, this one here that I'm talking, let's say that you're taking the point about it's where it is anchored for the other force. So the other force is going to be turning the body anti-clockwise. Do you agree? The other one is going to turn, this one going to turn the body this way. You agree? About, and so that force about 1. And the gap between them is 1. You agree? So the virtual the distance between it, the moment arm here is 1. And this is the force. So the force come like it tapping and coming through this point. And it turning, but it turning about this point here. And it turning about, say about that point that I be, and you're turning the one up top here about that point. So it will give you what now? So the force is, what was that force again? What that force value is? Can somebody remind me what was that? The horizontal one was 3.
3 times 1.
So it's 3 times 1. Who don't understand that? I think a lot of people don't understand that. The person who will understand, can you plug it up, please? Who are the persons who understand?
So can you explain once more?
So we are saying what all we did a while ago, and we use a different color. So for each component, for each force, it is a couple. So remember, a couple takes place between 2 points. It's a force and a distance. But once you see you have two forces. Let me see. Can I pick up the original diagram? I don't want to mess with that. Did I copy it or did I leave it somewhere? I took it. Yeah, the one here. So let's everything is in. I'm gonna take off a part of this. Let's see if I can use it. All right. So let's come back down. Let's talk about it a little bit. So we're almost done. We have two, I think one more little skill to go, but I want to just explain something. All right, so bring back this picture. It might not look pretty good here, but I'm going to want to put here because I don't finish up. All right, so what we're doing, if I could mark up this one. Nice right over here. Feel back the same color. Really funny. All right, so we have the components going this way. What is this one? Force. That is 4 kilo. And we have a component going that way for that. Same 4 kilonewton. All right. The distance between this point and that
Sir,
point.
the horizontal one was 3 kilonewtons, not 4.
Ah, thank you. Beautiful. Beautiful. Yeah, I'm tired now. You guys give me a lot of work to do. Not necessarily you guys, or it's not gonna write at all. It's still fine. Let me take up one from here. I think. Can I get a pink? Get a pink right. So it's 3. Oh, black. I could have sworn that I changed the color. It didn't change. No, I could change that. So this is 3. It don't change. All right, guys, it won't change. Let me just erase this out. Try my best, but it not. So what we're saying, this is 3 kilonewtons there. There's a 3 kilonewtons there. And this is the distance right between them. Right? But I don't want to let me look on that's the distance. That's 1 for them. You understand me? But that is the horizontal one. What we do, though, when you take in the couple, right? When you take in the couple, you have to take it against one of them. It's either you're going to use B, or if I call this one C, it's either you're going to put B as your center or C as your center. If I use C here as my center, So I'm putting my compass point right here. And therefore, the turning effect of the next component, right, is coming. Remember, the next component is coming along here. See there? And it comes right out here. So if you put your compass point right here, where I say that I'm highlighting, if you put your compass point right there at C, and the force is coming along, the separation point is 1. So their effect is going to turn the body into the clockwise direction. Can you see that? The one is driving that way, the distance between it. C is here.
Sir, wouldn't it be anti-clockwise?
Pardon me?
Wouldn't it be anti-clockwise in the anti-clockwise
Anti-clockwise, I
direction?
said. What did I say? Clockwise? Anti-clockwise.
Yes, sir.
Yeah, sorry. Okay. So this is 3, right? So it turn it, so that is it make the right angle. So you have to look at one between where the two forces are anchored and the distance that separate them. So for the component that are horizontal, is a 1 that separate the horizontal component. Right? I would do it also for the vertical component. We do the same thing. For the 5, we look at the 1 coming up, which is what, 4. And we look at the 1 coming down. If you choose to hold C again as your turning point, let's say C is a turning point, so therefore the distance that you between C to where that force lies is going to be 3 for the horizontal distance. So if you hold here so as your turning point, then this force is going to turn the body around here, that point. So it's going to be 4 times 3. And that is going to be what? Clockwise. You understand now? And you do that for each one of the forces. So you do it for the F and you do it for the 5 kilo. The F, of course, is 6 kilo, which you know. So you do it for the 6 kilo and you do it separately for each component. You analyze them between where they are. All right? Does that explain it? Does it explain it? Was that helpful?
Yes, sir.
All right.
Yes,
So
sir.
here now, this one work out. So let's go back. So this one works out to 12 minus 12, of course, plus 3 equals to minus 9. Was it? Yeah, it was kilonewton meter. All right. But the problem not finished. Problem says we're to find the determined resultant component. So the resultant component, you're going to sum. So the resultant component, you're going to sum M1 plus the sum of M2. Right? So M1 plus M2 will give you 3.804. So this give you essentially this is coupling resultant, which is really M1 plus M2. Right? So all right, so it's equals to 3.804, right, for M1, and M2 is minus 9.9 kilo. Come on. All right, kilonewton meter, right? So what's the difference here now? Put that in a bracket here.
Negative 5.196.
5.19 kilonewtons meter. I think that's all the problem asked you to do. All right. And right, so that's what it gives. Yeah, that's what the problem. And that is clockwise. Well, they said, well, so if you use the convention, so it depends on if you use anti-clockwise, you notice so you're getting it as minus. If you use clockwise, then you get it as positive. Right? So I think when this working out was done, they do it for the positive direction. All right. We use a negative direction, so we're gonna get the answer minus. That's the only difference there. All right. Where are we? Where are we? We're back up here.
We
Okay.
should still put the 6.
Pardon me?
Oh, it's supposed to be negative 5.196.
I don't get you.
It's supposed to be negative 5.196.
5.16, you said?
Yes, sir.
It means that we have
5.19.
along our way, we probably not using enough decimal points. They have
It's in the answer.
5.196. How much we get?
Yeah.
So it's 6 supposed to be there when you work it out.
That's why I got negative 5.196.
Negative 5.1 means that they use more decimal point than what we use.
Sir, use the value that you're actually presenting right now.
Yeah. Well, you can recheck it and put in some more decimal points. You will get it down to that. So this 9 flat, I think that is okay. The answer is probably lie right here. So you had 9. Yeah, well, we're not gonna worry about that. You just work out it to the lowest figure. All right. Yeah. So yeah. All right. Not worry about that too much. All right. So the principle is what you want to understand. All right. What else? The question, let me see. So that question, that's what that was asked. Yeah. So the answer is really 5.2. Eh? Yeah, 5.2. When they were working the answer, and this is from the text, I think they use certain decimal points. Once you use it right down to the certain factors. So like when you find the cost value, and you have it as 0.866, they would have used probably another digit down. Right? And that would give you the answer. All right. That's the difference. All right.
Okay.
Yeah, so that's pretty much. All right. I'm gonna try to get some time this weekend here to finish up with the. In fact, what I'm gonna do, guys, the link for your bridge project, I am going to drop it in the WhatsApp so that you can start work. Did I ever share the link with you for your software? Did I ever share that? Because I want persons to start
No, sir.
hold on.
But it's the name of the software.
Pardon me? All right, I'm gonna go on my other device. It's not on this device, and I'm gonna pull the bridge project, and I'm gonna drop the software into the WhatsApp group. If in fact, it's probably on Moodle. Did I put it on Moodle? Yes or no? But I'm gonna give you the specs. I need to give you some specs to work with for the bridge. That I'm still fine tuning those specs. But the software I want you to get accustomed to it. And I'm gonna finish tabulate the groups, and I will post the persons who are in the group. Now you have 2 to 3 more assignments to do. One, I am going to open. Let me just look at it right now while you're here, and I'm going to open one more of your assignments. Where is it? Looking for them. I need to get into your I'm gonna go on Moodle. Let's jump on Moodle. And I'm going to look and tell you. Everybody here now will know when is it that quiz 2 is due, right? You must work, or everything I can give you, you must work, those maths revision thing is crucial, But, right, so you need to be getting your maths up to the par to manage the work in the course. So don't take it for granted. I'm punching our password here and jump into this Moodle thing here. Don't hit lock now, thing. Come on. Reset me. All right. So when you go on Moodle, are you guys seeing what I'm sharing right now? I
Yes.
just see that we're in Moodle. All right. So we're in Moodle. Your course is right here. It's 4 courses I teach, so I'm tired. I have a lot of work doing. So here it is. It says here, but I'm gonna bring it forward because you have another one here. But this one I have to move this one forward. I think are you guys still seeing the maths revision? Oh, right. So you have this one doing now, right? But these are graded ones, so I'm gonna bring this one forward. Right. So I'm going to adjust the no, hold on. That's not what I want. I'm going to adjust we have done that one already. I am going to bring the date forward because I don't want to, we need to, your dates, let me see. We have done that one. This one is hidden. I'm gonna bring the date forward. The time for this one, I have to change. I have to bring it forward. We're at the 19th now. So I'm gonna open this right here. Yeah, sorry about that, guys. All right, so I'm gonna adjust it. I'm gonna let it be open tomorrow. I have to change this November date here. I have to bring it forward a little bit. About fourth, give you a few days. Let me see how many days now. If I put it the 20th, I'm gonna bring it up into October. Let's see how many weeks. How many weeks you have now? Because I don't want everything to pile up on you in the latter part. Let's just check it. So today is the 19th. I'm gonna give you a few days to do it. Not gonna give you more than up to the 24th. You can do your research, read up, practice, as I just help you to practice some of the core areas on this section. Core areas are that you'll be getting in this section is I will post it. I'll just double check and post it. Has to do with moments and equilibrium forces, some areas that I've just dealt with. So you need to comb through those units very well. Right? And the time, let me enable time. I am going to give you 50 minutes is probably too much time, but I'll set it as that. All right. And how many chances I'm gonna give you? I will go back to how many tries? Not more than two. Not more than two. All right.
So is it possible for us to have another revision for moments of inertia another time?
Oh yes, sure. Sure. Yeah.
Sir, on Moodle, the year for us for assignment 2 is 24 and 25, not 20 and 21.
It's what? Let me go on.
That title for assignment 2 is different from what's on Moodle.
Let me look. Let me look. Because I'm using some stuff from before, but if it has a date issue, let me see. So course schedule, that's not yours. Anything that you see not highlighted, your page, you wouldn't see some of these things that you are seeing on mine. So you have that one. Oh, there's a bridge thing here, but I'll fix that up. It's supposed to be here. I'll check through that. The bridge thing you're supposed to. All right, hold on. So I need to check through this to see what's there. Where is it
But
here?
sir, I did something called assignment 2 yesterday, and it was just like a different version of the vectors quiz that you gave.
Wait, hold on. Let me just check. Which one is this? Hold on. This is the one that I told you should be open, right? So I look through it and check it. Hold on. What did I open a while ago? Because I have to make sure it's the right thing I opened. This is your thing. Am I in the right group? I have several courses. Let me make sure I'm in the right course. Engineering mechanics, statics. Oh, I'm sorry, I'm in the wrong course. I'm wondering why that one looks so. It's supposed to be in your course. This one looks more like your course. All right, so you got that one already. And you're supposed to be getting this one. All right, so you want some date change here. It is 20, 24, 25. And then we change that date. All right, so that's that.
Sir,
Mm-hmm.
sir, assignment 2 closes on Sunday for me.
Which one? This one?
Yes, sir.
On Sunday? No, I just fixed it. There's 20 open and I close it there just to edit it. And I'm gonna fix up this one here. Well, I need to review this one. Let me just change the date still. I'm going to review this one to see, sure that it is applicable to you guys. This is 25. All right, so you notice it says to you that one was unit 1 and 2. This is unit 3. So unit 3, remember what unit 3 was in? Unit 3 is moment and couple. See it there? So unit 1 and 2 you did before, unit 3. So the next one coming up is going to be centroids and frameworks. Right? So let's go back to that page. So centroids and frameworks is coming up here. We don't do frameworks, right? That's the next one you're going to be tested on. So I'll make sure I check this that is applicable. And I review this one already today. And it's applicable. So it stands. So those are the other 2 assignments you have. What I am going to do though, you guys have a lot of questions already. I don't even need to give you any more questions. You are good. It's the other class that I have that I'm going to throw a lot of questions to them. Right? Because they're probably taking it for granted. What is this? Revision class. I can make sure that this is available to you guys. I edit it. 24.
So sir, is my assignment 2 messed up?
Pardon me? Meaning, what do you mean by your assignment to me, sir? Check
The
now.
quiz,
What are you seeing?
it was units 1 to 3, like the first one.
Unit.
And you use back like some of the questions, but the questions at the end were different.
For here?
The one that's labeled assignment 2 on Moodle.
Here. Yeah, man, they should be all right now. I'm gonna recheck them after I log off. I can't check them with you guys. I'll have to recheck it. Remember that I just make it available tomorrow, but I'm gonna check it. So you get how many days? About 3 days to do it. Yeah, 3 to 4 days to do it. So what's the calendar saying here? So you got it Sunday, Monday, Tuesday, Thursday, Tuesday. So everybody should be aware, right? It's currently hidden, and I'm going to show it to you guys. But how you guys seeing it? You're not supposed to be seeing it. It says hidden.
Sir,
Well, why did
because,
I do it yesterday?
sir, it said it was due tomorrow.
I saw
No,
it
that one
today.
is probably, so if that one, what is that? I'm gonna look to see what you guys see. Let me check and see what you guys see. Hold on.
It said quiz tude.
I'm going to look and see what you guys supposed to be seeing. So I'm going to look what you guys see. So that one, and tell me what you're seeing. Where is it that you're seeing? That is practice.
Assignment 2, that one right
Oh,
there,
this
yes.
one. Oh, you guys seen this? Where this come from? Where this come from? I just changed something here. Oh, all right. I am going to try and figure out. I have an assignment for here. Oh, where is this coming from? I need to figure out what is going on in my movie. Because I am seeing, you see on my page, you see one setting, don't? And now I'm seeing that you have, so that there's a glitch here. I'm gonna figure out this because you're not supposed to be seeing anything away from what I put here, but you're seeing something totally different. Assignment 3,
So
4.
that means we shouldn't have completed that quiz.
That quiz, hold on. Because I deleted some quiz, you know. I know I went in and deleted some because you see this one is going to be too late. It's I have to change these time. By November, all the quiz and everything's supposed to be wrapped up. So those things revision thing, I think that you have that doing. Mass revision, but they have it as an assignment given here. I think they mark it. You guys did this one.
Yes, sir. Is that the one that you
Yes,
said you weren't
sir.
going to use as a grade? You just want to see where we were?
But you know, when I review it, how many questions is in this one again? How many questions?
51 questions.
Pardon me? How many
I
questions
think
was
it's
it?
51.
51?
51.
I don't think necessarily. If it is a lot and I might not use it because it's of revision. But you need to do it, and you need to do every one of them to bring you up to speed. I need to check because I am not seeing that. I went in and I clean up my thing so that I would. So let me switch back and go back to my normal. All right. So you notice in my page some of these things are hidden from you. You are able to see that one. And was this the same date that you have on your own? I need to this one. Where's the math? There's a math revision, which is different. Let me see. Where's the math revision? I think there is a math revision. See down here. I think this is the one that you're talking about. Oh, this is the one that you did yesterday. Is this so?
Yes.
Oh, so there are more than one on the page here. Hold on. Because I kind of reformatting the page, Hold on. I need to look and see the content of it, guys. I'm gonna have to go realize there's too many quiz here because some of them, I'm gonna check it. Some of them would have been before. I just changed the date on them, so bring them up forward. But hold on, but then I have some others up here that I am putting up here. But hold on. So I'm gonna have to check the duplication. All right, I'm gonna have to check the duplication before I make any decision. Since that you did it already, I need to review the questions, see if they are applicable. If not, I'll ask if we redo it because something is wrong. I can't have anything coming down in this period here. So when they reset Moodle, they would have bring over some material from previous lectures, and I would have to go in and clean up the page. But I thought that I pretty much clean up most, but now I'm seeing some more down here. There are more down here. So you guys seeing more down here. All right, I'm going to have a look in this page here and sort this out because too many things here. I'm gonna have to delete some of these things off. There are too many of them. I'm gonna have to delete some of them off. They are confusing. I am going to remove them. Yeah. You see, for the midterm is only one. You guys not gonna see these, only me. There are a couple of them well here. Formula sheet and all sort of stuff. With design and stuff. Okay. You guys are seeing these. Let me see. Oh, hold on. What is happening down here? How much are these things down here? I show you a couple of them. What are you seeing here? We see lecture one, and I put the card in. You'll have seen some of these. But then no, these others, all right. There's quite a bit here. So there are some recordings from other lectures. I'm gonna release these recordings since that they are there. Let's see. I'm gonna release the recordings so you can watch those recordings too. They are very good. I don't have a problem with that. So you can watch their recordings. Once they're recording down there, we have quite a bit. Don't even realize how much of them down there. So it does static. So there's a recording. I release that to you. Lecture 2, that's released to you. I can release this one too. So, tutorial recording. Yeah. So let's show it to you.
So, sir.
You see those. Recording. I'm releasing everything, so you can just watch those videos. Help you. It will help you. I didn't even say it.
Sir.
Yes, go ahead. I'm not gonna delete them.
If we have not, or should we wait until the page is updated for us to continue with the quizzes, or do we
Yeah,
go
all right.
ahead
So I'm
still?
gonna go in and I'm gonna regularize it because obviously there are a lot of duplication here. Some of these things are gonna have to I wanna have to delete some of them. Whatever not, it's just resources. So some of these resources, I don't show you all of them. But I can see this one on recording. And Equilibrium. I can show you that too. You can watch them. Anything that can support you, I'll show you. So they would have probably go through some of the same questions that I have done, or others. Coupling, yeah, you can see that. There's a recording here. There's one here, and there's a recording here. Let me show that to you guys. No problem with that. Yeah. All right. So, but what I don't want you to spend, well, if there are several recordings, watch what you can watch. You won't be able to watch everything. But on all of the topics, they would have had recordings. So the other person's teaching the course, previously would have done.
So,
Yeah.
excuse me, sir. So is it a case that we're not supposed to do anything until you confirm it?
All right, don't do anything. I'm gonna confirm what, because I just opened my quiz, but I realize that you guys are seeing some stuff. It means that I have to go delete some things off of your page. I have to go in and delete what you're seeing and what you're not supposed to see. Yeah, because I didn't come down. Wow, that's quite a bit down here. All right, so I'm gonna have to look on the full page, go back and see what you're seeing again to make sure that let me see everything that you are seeing again. So you are seeing assignment 1, which we did. Yeah, lecture, and there's a recording, no problem. Revision class. Assignment 1, so you have math revision there, that's not a problem. This is the problem. The date on this on your thing here is wrong. We have that. These are shaded out. So these are what you're seeing. These are what I need to fix. This one right here. But I just thought I fixed it a while ago. Is it not updated on your sheet yet? I have to. All right. What I'm gonna do when I'm off, I'm gonna look to see what is this one, and let me go through it. All right. So I will reset the date. I have it as starting on the one. Tomorrow,
Excuse me.
I'm gonna put it back at it. So I get to check the side.
Excuse me, sir.
Yes.
For the math revision, I wasn't aware that it was on Moodle, so I didn't do it.
Why you didn't do it?
I wasn't aware that it was on
Moodle.
Moodle.
It must be there. You must be checking Moodle. You must be checking Moodle. And there's a lot of questions because some of you come in and don't have the prerequisite maths. And that is why it was placed there. And it's critical. All right. So we don't have time to teach you everything. And they probably would have even recording of, I don't know if is there a recording really to, of any math revision. No. Nobody had any time to, it's just a revision class. We don't have the time to go through everything. So that's why it was put there for you to go and practice. Yes, I see there. They actually put there, what they did, they actually put it as a grade, you know, so you get 4 pieces. First piece of work plus your bridge to do. And I think I'm gonna keep this formatting. But what I want to do, yeah, I'm gonna keep the format. It means that for those I probably can reopen this. If it's closed, I'll reopen. All right.
Sir, could you please repeat that?
If for the assignment one, if person missed the math revision, I will reopen it. That's saying that it's closed on your thing.
Okay.
Right. And this one now I have to check because I am not on my thing. I just went in and checked the date. So maybe the system needs some time to adjust it.
But sir, are you understanding that I'm saying that that quiz is a different thing than you're saying it is?
I am going to look. Let me look and confirm. Let me look. Because if you are seeing a different quiz from my quiz, it means that the system have a problem. But so I'm going to look at it. Outside of your thing, I'm going to look at the quiz. So you would have done this quiz. That's what you're saying? This one.
Yes, sir. And it's
Yes.
unit conversions and vectors.
Unit conversion
Yes.
and vector because I deleted some stuff still, you know, because I thought there are too many duplication. I deleted some stuff off of my page, you know, because there were too much, the page was too cluttered and I need to manage it. So really and truly, guys, I should go in and clean up the page. I clean up some part of it, but I didn't reach the other sections yet, so I didn't touch them. There are a lot of materials that they would have brought over from numerous years. So if there is a problem wherein I don't have a course and it is reflecting on your page, then I have to call the system administrator to help me to rectify that. So guess what? I am going to look at at it. I'm gonna spend the rest of the evening. I'll run through it to see why you are seeing it different from mine because I just adjusted it right here. So you're not seeing it. It says, you notice my quiz is even hidden. So you're not supposed to be seeing my quizzes are hidden, you know. These are
Sir, it
hidden.
look like it's two different quiz because the quiz that we did is quite similar to the first quiz that we did.
So
So it look like it's two assignment two.
hold on. So all right, guys. It means that we have some problem with this thing. We're gonna fix it. We're going to fix it. Don't worry. We're gonna fix it. Thank you for alerting me. Because you notice how my thing is structured here. I have unit 1 and 2, unit 3, unit 4. I'm gonna bring the time up. That these times we are gonna adjust it, but I don't reach them yet. So, and I know I went in and I deleted it. There is an old one, you know. I wonder. Let me go back to dashboard. There is a 2024 and different year that used to be showing up. Used to be showing up for all the courses that I'm interacting with. Let me see. So these are all my courses that I've interacted with. So is it that there is a previous year that you are seeing? No, that's not the right one. All courses. So all my courses that I've interacted with. Let me see. So all my courses are here. That I've interacted. Some are in previous years. Some of them I'm not even, I'm registered here as well. Oh, so here I'm right. I'm there. Right, so I'm here. I'm just trying to see if there's any duplication. Uh, trying to fix it, right? So all right. Um just looking. Well, they all seem all right here. They all seem here. I don't have a problem here.
Sir, maybe it's a case where all the old quizzes from other lecturers are showing up instead of yours. So maybe you could try and work that out with tier one.
With who?
Tier one, because I think they're responsible for Moodle and that's
Okay. All right. Thank you. I
you're
will have to investigate it because now I'm realizing that what I am setting and what I'm seeing. Because I went in and I started deleting some of them, because there were too many duplications here. They were even confusing me. So look, you see all of what I'm seeing here. So what I have, let me see. Hold on. This is what I see in here now. Hold on. What is this here? Hold on. There are so many duplications here. Can I have that one that I sent for you guys? Then this one, oh, see, not available. Let me see what is available here. There is here another set that is, oh, so it's down here, so see it here. Down here, so these. All right, see it here, guys. See them here. These are the ones that you are seeing. I'm gonna check them too. Let me check them through these because I have some up here so also. Notice I have some up here so too. I was working with this section up here. All right, guys. All right. Let me go through and look at them. What is not concerning you, I will delete them off the page. So I'm going to. You say you did a set. Let me review that set that you did. If it's not applicable, I'm going to remove it and you just redo it. But I will check it and I'll check the grades then before I do anything. So if I'm going to remove it, I'll download the grades then if I think it's not good. If it's good, I'll leave it. And I'll just duplicate it and carry it. So give me a chance to fix that. That one that I say gonna start tomorrow, I regularize it. But continue preparing. You did unit one already, right? There's too many duplication here. You confusing me too. I didn't realize that in a full picture that it have some more there. But 2 layers of assignments there. One up here, another one down here. It's too many duplication. It brought over too many assignments. So this says midterm solution, and then this says revision, and then it says, and then it's have an assignment page here. So it duplicate. It brought over too many here. Right? Look how many of them. I don't show them to you, you're not seeing these because I haven't opened these. So I probably have to delete them off of my page. Yeah. I will ask them the ramification if I delete them if they're gone forever, or is it that they'll be there. So that's also a reason why I don't jump to delete some of them. But let me talk to the system administrator. I'm gonna run through them and I'm gonna fix it. All right. So don't worry, just practice. But I'm gonna fix it. I'll bear in mind that these are open for you already. I think these down here, these. Oh, so I have all of these open. Hold on. So I have from here. So this would be, yeah, I'm gonna look on all of these that I have here. But these dates are not going to be my dates at all. You see, you're not seeing these. You'll be seeing, oh, so you're seeing just these. So, all right, I'm gonna look back to these. If these are not what they're supposed to be, I'll make some adjustment. And then I'll hide, if so be case, I hide these. Oh, okay. So, right, these now wasn't here. Yeah. So you'd have done this one. This assignment one, would you guys have done this one? This one says 2022. Hold on, let me see what this one says. I probably need to delete those off the page. See here? That is that. That is this. All right, I'm gonna check these two. And if this is okay with me, I'll fix up this page here so and delete the others. I'll just delete everything up here. So there won't be any confusion. These, I'll just delete everything and I'll hide them. Right? If they're causing confusion, I'll just delete. And I will do the tallying of your numbers. All right? For your bridge. So that's the intent. This weekend I'm going to sort out the numbers, the bridge report, and I'll check the field and fix it up. So, all right? Because you're gonna do everything, you're gonna do your midterm online still. So your midterm exam is gonna be done online. All right, guys?
Yes, sir.
All right, great. So a lot of persons supposed to go on by now. Only 12 leave. I'll sort it out. All right, cool. Oh, I didn't stop the recording, eh?
Also about the math revision.
What about the math revision?
You had said that you were going, the persons who missed it, you were going to re-upload it. So just so
Oh, yeah, I will let me assess everything first now before I make any decision. I will tell you what I'm gonna do.